All right. So now we have the other weird relational formula. And this one has four unknowns, just like our law of sines. It's just the things it relates together is slightly different than law of sines. Law of sines has two angles. Law of cosines only has one angle. There are three different versions, but if you relabel things, it's really just the same formula three times. So what you want to pay attention to is alpha here goes with A, beta here, B there. If gamma is here, then C is here. Notice the rest, I've got A, B, A, B. So it follows a pattern. We've got at the ends, I know my angle, I label it. The side that goes with it is going to be way on the other side of the equal sign. And then the first part of it is like a weird Pythagorean theorem. So the one I actually usually memorize was the third one because then it was c squared equals a squared plus b squared. So I was like backwards Pythagorean theorem. And then minus 2ab cosine gamma because gamma goes with the c squared that we started with. You guys get a formula sheet, so you don't have to memorize them, but you do need to be familiar with the labeling and angles again. So now we're just gonna play around, see what these formulas do. So we're given a side angle, side triangle. So we have an angle, but we do not know the side opposite it. We do know A and C though. So since they've labeled it for us, we know beta. We want to figure out B, so we're going to use that form of the law of cosines, the one that starts with B squared. Then this has to be A squared plus C squared. So B squared equals A squared plus C squared minus 2AC cosine of, we started with B squared, so it will be cosine of beta. And now we're just going to fill in the stuff we know. So this is B squared is thing squared plus thing squared minus 2 times thing times the cosine of thing. All right, A is 10. C is 12. And cosine of beta is 30 degrees. All right. Now, here is one of the flubs I learned from last semester. Students had a habit of they do 10 squared plus 12 squared, add that together. Then they would subtract 2 times 10 times 12 and hit equals, and then multiply by the cosine. That is not the same thing. Order of operations, we have to multiply all this crud here, the 2 times 10 times 12 times the cosine of 30. So I'm going to add in like an extra set of brackets here to say that is all one multiplication product. You can't break it up. What I really recommend when you're doing this, everything on the right side is numbers and functions. All of that, I can type it as is in the calculator, hit enter, and it will give me a number. Do that. Do not break up the steps. Type it all at once. So 10 squared plus 12 squared minus 2 times 10 times 12 times the cosine of 30. Make sure you're in degrees, equals. All right, so I got this number, 36.1539, blah, 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 blah. And it's like, all right, I plugged the numbers in, I did the long calculation. What does this equal? B squared. I want to know what B is. So what do I do to undo a squared? To cancel a squared, I square root. Anytime I write the square root, I have to consider the plus or minus. If b was negative, we would have a negative measured side of a figure. Distance is not negative, so we can ignore the negative square root here. So there's like a plus or minus plus, because negative side is silly. I know in like physics or whatnot, sometimes you use negative to indicate direction and it might have meaning, but for what we're doing right now, no. I give it another week, maybe. So I take this and I don't want to, I'm going to use my exponent and put 0.5. That's the same as square rooting. And I get 6.0128. All right. So I did some work. I have another thing. So up here, I know this is now 6.0128. Add 0. So now that I know B and I know the angle that goes with B, then I can use law of sines to find one of the other two angles, and then the three angles have to add to 180 for the third one. So now it's a question of, do you pick, so the 6.0128 is the smallest side. I tend to go with the next smallest side for what I'm going to find, because the largest side is going to be across from the largest angle. The largest angle might be bigger than 90 degrees, and law of sines flubs when it's supposed to give us a number bigger than 90. So find all the small things, small angles first, use the 180 to find the biggest. All right, so we have the sine of alpha over 10 is the sine of 30 over 6.0128. So the sine of alpha is 10 times the sine of 30 over 6.0128. And then to get alpha by itself, we have to use our inverse trig function of the whole ugly fraction. Okay. So 10 times the sine of 30. Oh, sorry, back up. Inverse sine of 10 times the sine of 30 divided by the 6.0128. All right, so alpha is 56.2592 degrees. So I got 30 degrees and this 56 degrees. Add that and subtract from 180 to get gamma. And we get 93.7407 degrees. Now, just real quick, I want to show you what would have happened if we did the sine of gamma, which side C was 12. All right, so sine inverse of 12 times the sine of 30. Close that, divided by 6.0128, close. This calculation told us that gamma was 86.26. All right. So if I used this and my 180 and my 30 degrees, I would get alpha as the biggest angle. So if you're not paying attention to which angle you're solving for, you might get the wrong one. So this is why whenever you finish one of these, it's always a good idea to check, is my biggest angle with my biggest side. So just to be very clear here, this is wrong. The correct answer is 180 minus 86.26, which is what 93.70, etc. is. All right, so if gamma is 93, that's across from the 12. Alpha is 56, that's across from the 10. Beta is 30, that's across from the 6.0128. Smallest with smallest, biggest with biggest, the others are in the middle. These are correct. But you need to have that kind of gut sense to make sure, because it's really easy to choose to solve for gamma instead of alpha here. Like you have to know from experience that law of sines can screw up when the angle is bigger than 90 degrees. All right. So another side angle side. So alpha, I'll put beta over here. So this is 30 degrees. B is 12 and C is 24. So our first thing we're going to find is A. So we need our law of cosines that starts with A squared equals B squared plus C squared minus 2BC cosine alpha. Now we just fill in the things we know. We don't know A squared. B is 12. C is 24. And alpha is 30 degrees. And now lots of typing. 12 squared plus 24 squared minus 2 times 12 times 24 times the cosine of 30. Make sure you're in degrees. Put my little brackets to remind you that is all one thing. So A squared is 221.169 whatever. Raise this to the 0.5 power. So our A is 14.8717, whatever. So 14 something. Okay. Biggest side is C. So I do not want to find gamma next. I want to find beta next. B is the smallest side. So I'm actually going to get something smaller than 30. Yeah. Smaller than 30 degrees. 30 degrees is opposite the 14.87. B is 12. So beta is going to be smaller than 30 and gamma is going to be huge. All right, let's set it up. Sine alpha over A and sine beta over B. So sine of 30 over the 14.87 we just found equals the sine of beta over 12. So multiply both sides by 12. So we have 12 sine of 30 over 14.87 is equal to the sine of beta inverse sine to undo taking a sine. So now beta is that crazy calculation. Inverse sine of, open parentheses, the 12 times the sine of 30, close for that little angle, divided by 14.87. All right, this is telling us beta is 23.7969, blah, blah, blah. So smaller than 30. So last step is just finding gamma. So 180 minus 30 and minus the number we just found. And there we go, 126.203 degrees. So we had to use law of cosines to find A. Once we had A, we could go back to law of sines. Now you can technically, well, we're going to see that on the next video. If you only have 3 sides, you can use the law of cosines to find an angle. It just looks really hairy. So we generally try to go with the law of sines as much as possible. All right. So I'll stop this.